Welcome here to GOTO Chicago. My name is Jørn Larsen. I'm from the GOTO organization. We have two guests here in our little studio. We have Doug and we have Danny. And maybe you can tell a little bit about yourself and your background and your passions in this space, which is, of course, general artificial intelligence.
Sure. Well, I was a physics major and got some bachelor's and master's degrees in physics and got far enough in physics and mathematics to realize that I wouldn't be the world's greatest physicist or mathematician. And that even if I made progress in those areas, it would be a long time, if ever, until they really had a positive impact on the world. And I looked around and tried to think what would improve the world in a significant way. And I realized there were really two paths, one involving molecular biology, genetic engineering, and one involving AI. And at the time, which was the late 1960s, there were already a lot of very smart people working in the biology area. But in AI, it was clear that it was like the Wild West in America. It was an open frontier. And that was the path to increasing human intelligence. That was the path to really leaving a positive mark on the world. And so I went into AI, having never taken any kind of computer science or AI class, got a degree in computer science, became a professor at Stanford in computer science, did AI work in machine learning, in natural language understanding, in expert systems, and even a little bit in robotics and so on. And I and my colleagues kept hitting this brick wall, which was our programs had the veneer of intelligence, but they wouldn't scale up because they didn't have common sense. And I realized about 1980 that somebody had to do something about this, and that it would take thousands of person years of effort, and I wasn't going to live to see the end of it with 5 or 6 graduate students. And so I moved to the wilds of Austin, Texas, formed a company where we have 10 times as many people. And now, 35 years, 40 years later, we're just at the end of that long journey, and we've actually got something which I think is the core of a general artificial intelligence.
Thank you. Danny?
Yeah. So I'm VP of AI at Unity Technologies. We are a game engine company. We're the most popular game engine in the world, powering 60% of all games. And AI has a very, very, very interesting role to play with game engines. It can play the role of behavior in NPC, that's non-playable characters, inside games. You can also use it to test games. And then thirdly, you can actually use the game engine to provide simulation data for algorithms to learn from these simulations. And I think that's a common theme of what I've been doing in my life is always operating at scale. When I was head of machine learning at Uber, we built a very scalable cloud platform for machine learning for the company. I ran elastic machine learning when I was a GM for machine learning at Amazon. I also launched the first AWS service for machine learning. It's all about scale. And that has been where I believe that Unity can provide a distinct capability to AI researchers. 1 machine, 10 machines, 1,000 machines generating massive amount of training data at extreme low cost.
Mm-hmm. Thank you. So we'll kick off the discussion here with trying to define what is AI and see if you agree on that or you have just 2 different versions. So Doug, would you like to start with sharing your view?
So it's very slippery to try to define artificial intelligence, but maybe a better way to think about it is how will you know it when you have it, or how will you know it when it exists in the world? And I think the right way to think of it is kind of mental amplification or mental prosthesis that will make people smarter, more creative, able to do more things in parallel, able to misunderstand each other less, and so on. And as a result, we as individuals and we as a species will get qualitatively smarter The good analogy is 100 years ago what electrification did for our muscles, where we're able to travel faster than horses' legs can carry us. We're able to communicate farther than we can shout, and so on. And it's that kind of ubiquitous amplification of a muscle power that really changed the world. If you look back, when was the last time human intelligence was really amplified? It was all the way back at the development and discovery of language. And we look back on pre-linguistic cavemen with sort of a mixture of fear and loathing, and essentially say they weren't really quite human, were they? And I think once AI is here, people will look back on us with exactly that same kind of pity and say, well, it's nice that they developed AI, but they weren't really human, were they?
So it's something that can extend us and enhance us rather than something that will stand alone?
Absolutely. I think that there will be inevitably, and in fact there already are, standalone AIs, but the combination of human intelligence coupled with and amplified by machine intelligence is really going to define the future of humanity and really going to define the future.
And
Yeah, I have a somewhat similar definition to AI, at least when you start out saying that AI, you know it when you see it. I basically take a step back and say, well, let's just, instead of the artificial part, let's just look at intelligence. And intelligence is something that we see around us in nature. We see it in not just in animals, but in most beings. There's some level of intelligence in surviving. Yeah? And when you put the A in front of it, the artificial part in front of it, I think it's when we have computer systems that demonstrate some of the same traits, with one very important amplifier in there, you use that term too, which is what I call the feedback loop. I think it's very important for artificial intelligence that there's a feedback loop, that it's not just a smart algorithm implemented, compiled, shipped, but that it's an algorithm that generates data, consume data, and learns from it and gets better and better and better.
I think there's one additional element of intelligence that's important to call out, which is something you might think of as self-awareness or consciousness or modeling, but it doesn't have to be consciousness in the way we normally think of it. Just think of it as the AI can and should and will have a model of its own self and its own capabilities and its own situatedness in the world and its own functioning on things. And it will be able to correctly answer questions and make decisions about what it was doing and why and when and so on. And it's something which, from our point of view, looking at another person or looking at an AI, we might ascribe consciousness to it. But I think that kind of self-awareness can be built without any kind of mystical, without any kind of mystical input or anything added to the purely mechanistic representation of knowledge, the purely mechanistic and algorithmic capturing of the sorts of processes you were ascribing to almost all living systems and biological systems, namely to defend and procreate and to explore and to understand that if they're going to accomplish their goals, they're going to have to learn more about their environment. They're going to have to exhibit things which, again, from our point of view, we might label as curiosity or innovativeness. But again, there's nothing magical or mystical about that. That can all be represented explicitly, and programs can do those sorts of things.
Okay, so you both received very high ratings at our conference, so thank you for really bringing the quality up at our conference. Thank you for that.
Thank you for having us.
Yes, you're welcome. But actually, why I bring it up is when the attendees here at GOTO, they vote for the sessions, we will actually plant a tree. So this is kind of the reward function that we have for our attendees, so because we like to have the feedback. So my quick question there is, or just follow up from what you just said, is a tree intelligent?
I would say not in an interesting sense, even though it carries out some of the biological
feedback.
Yes, some of the biological processes of all living
DNA.
systems. Yes, but there was a good book by Miller called Living Systems that actually talks about different levels of biological organization, from the organelle to the cell to the organism to society and so on, and talks about how at each level all of these different functions are carried out, and how different solutions have been found for offense and defense, and getting energy and storing energy and converting energy, and sensing the environment and so on. It's a very interesting idea, but from my point of view, while trees do all those things, they have found solutions which are in some sense uninteresting because they are very slow, almost like the Tolkien Ents, where they found solutions that work for them, but they work for them in ways that make them uninteresting and unable to adapt in interesting ways to solve novel problems. The way they solve novel problems is to hope that other trees elsewhere survive.
Yeah.
I wouldn't use the word uninteresting. I would say that it's hard to understand, it's hard to interpret. I think that trees, plants, does have a degree of intelligence. It's just for us animals really hard to understand. The time scale is different, the problems are different. Remember, we can always run, they can't run. So they build a complete different system to stay your ground and defend yourself. So I think it actually raises another problem, which is when you actually see intelligence or experience intelligence you haven't really seen before. How do you know it?
Sorry for bringing it up. No, but I would say that's actually what I meant by them not being interesting. Namely, they may be intelligent in one sense, but it would be boring for me to try to have a conversation with them. And the way I recognize intelligence, say in you two, is that I know that we can have and we are having a lively conversation. If there were a fourth member of our group, which was a tree, I believe that even you would agree that it had the least interesting contribution to the session.
But they may have seen more and lived longer. But let's just continue. Okay, so we talked about AI and intelligence, and so getting back to the artificial part, so the man-made part of the intelligence. So what is the real world potential? So what can we, what's the potential?
I think the potential is huge, because I think we're going to have systems that are essentially smarter than we are. And we're going to need that. If you want to build a self-driving car, it cannot be a robot. It cannot be developed in C, engineered like a robot, engineered for all cases that it's going to meet in real life. Not happening. It has to have cognitive skills. I mean, like, it has to be able to navigate and understand problem. It has to have seen many problems before and learn from them and learn how to generally solve problems. And I think it's an illusion to think that you can sort of hardwire a self-driving car and put it on the street. It needs to interact with bicyclists, pedestrians. It needs to understand children's behavior versus adults.
Backs on the road.
It needs to deal with weather, etc. I don't think that you can sort of take a little machine learning and do that, or a little C engineering and a little robot programming here and achieve it. It's just impossible. We have to have much more human level cognitive abilities to have a car drive the streets. And I could mention many other tools.
Okay. Since I completely agree with what Danny said, I'll find some other way to answer your question. So I think that the potential for AI, if you look at the potential, what was the real impact of computing? Yes, it's true that at the end of World War II and in the next decade, there was some impact of a small number of large computers. But the real impact came when computing became ubiquitous and omnipresent. And I think in many ways, the real potential for AI is when it becomes omnipresent and universal and ubiquitous, that it will transform the world we live in into what Alan Newell might have called the land of fairy, a world where every single person growing up in that world, when they walk up to a door, will just assume they could talk to the door if they wanted to. They could ask it questions and the door would know things that a door in that place ought to know. That they'll be able to talk to more or less any object in the world and have essentially whatever reasonable conversation they need to have with that object as if it were an animated thing. And growing up and living in that world, especially from birth, a generation or two from now, I think people will be able to have a completely different experience of life as we do. They'll have a life that's really more like characters in fairy tales.
So what about when all those things start talking to each other?
Well, I think that that's going to be a good example of why we want to build in from the beginning, rather than letting it evolve. We want to build in a model of what it means to be moral, ethical, what it means to be altruistic, what it means to look out for the common good, what it means to cooperate, what it means to be just and fair, and so on. And that if we let those things evolve, then maybe they'll evolve as well as humans did or better, but maybe they'll evolve as badly as humans did or worse. Have you met people? So I think that it's one of those things where we have a responsibility to not just invent technology which can become intelligent. We have a responsibility, just like any responsible
laws and rules.
Well, and like any responsible parents, we have a responsibility to bring our AIs up right, so that in fact they have the best chance of being responsible citizens when they interact with each other and with people.
So we want to give them a moral compass.
Yes.
Okay. So what can it do right now? What's the most advanced thing that you know of that we use AI for today?
Playing Go, playing chess,
Yeah.
playing computer games. That's really what we're looking at today. We shouldn't underestimate that. There's very complex stuff going on in there, but it's mostly what I would consider somewhat simplistic single agent systems. There's no collaboration. There's no collaboration patterns in there. Everything can still be, it's being engineered. But it's the roots of the core entities that we're going to work with to take AI to the next level. So it is reasonable, smart systems. I mean, like beating the human in playing Go. There's very complex decision making in there. But what if I have, 100 of those systems not playing Go, but learning to cooperate, creating their own collaboration mechanisms, creating their own communication patterns, so that they can achieve, solving problems of some kind. That's when you're gonna that's when you're gonna see the real impact of this. So today we are at this very entity level where we have some very basic intelligence, and it's doing impressive things, but it's not changing the world necessarily.
What about in medicine? You had some examples in your talk from medicine and how you are helping making maybe better decisions or second opinions.
One of the things that humans suffer from are various sorts of cognitive limitations. Things like confirmation bias. Even if you're the world's expert, when you come up with some hypothesis, it's very hard to objectively put that aside and think of the second best answer and the third best answer and so on. And there are many other sorts of cognitive biases like that humans suffer from, like the regression to the mean phenomenon and so on. And I could go on and on, there are many, but the applications which I find most powerful, most interesting that AI is already able to help with is almost a kind of counseling type of application, which essentially says, that's really nice, but are you sure there isn't another way that this could happen? So let's generate a bunch of scenarios, and even if you don't like any of these, maybe some of these will spark another idea in you and so on. So I think there are AIs out there already which are helping people to be more creative and to be less brittle in terms of their approaches to problems. We see that in, for example, scenario generation for counterterrorism, where you really don't want to just imagine and defend against the most likely attack, even if it really is the most likely attack that's going to happen next. You really want to defend everywhere. And so you really need to imagine many different scenarios and think about preparing for all of them. So I think that the best applications of AI today are ones which help scientists and engineers and doctors and intelligence officers and so on to think outside the box a little bit and to come up with solutions that they otherwise would have missed.
I guess also pattern recognition. If you just have a lot of data, I mean, not like you have created a lot of data, but like look at the stars, look at the CERN experiment where you collide particles. That you generate a lot of data. So I guess that's also a useful application.
One of the things we found with deep learning is the ability of a deep neural net to learn very complex functions such as modeling in physics. So basically predicting, computing a lot of trajectory information will, by giving it enough data in, it will actually learn the physics. It will actually learn the formulas behind the physics. Not that you can go in and look inside your machine learning model and say, there's the function, but it learns very complex functions, and that has been one of the breakthroughs, is to be able to basically, through very large amounts of data, to learn these, what you call patterns, and turn them into functions. Very, very, very complex functions.
Okay, so that was some applications and some potential. So let's talk about where it struggles.
Well, I would say, following up on what you just said, it struggles in the very thing you identified, which is it doesn't actually understand, in the sense that we can understand and articulate, the intermediate concepts it's forming and the intermediate clusters that it's forming and so on. So as a result, it has a difficult time articulating in ways that we would understand why it's come up with the answers that it's come up with. And in some cases, the decisions are so important to us that it's very, very difficult for us to trust an entity that can't explain itself. We've all had the experience, I think, of having gone to some doctors, for example, some physicians, who were very good at explaining their reasoning, versus some physicians who basically just essentially said, "Trust me, I'm the expert." And the visceral, qualitative reaction to those two different kinds of physicians, at least in my case, is very, very extreme, where possibly because of being an engineer at heart, I really want to understand, and I have difficulty trusting an agent, even if they have a good track record of correctness, if they aren't able to explain in ways that I can understand how they got to some conclusion.
I think that we should look at machine learning today as we have convolutional nets, we have recurrent nets, we have some basic mechanisms. I would say that the state of the art today is, if I want to look for an analogy, is maybe the programming languages of the early 60s. We have spent, enormous resources inventing the equivalent of an if statement, the equivalent of an assignment, for loops, while loops, and now the next 10, 20 years, we're going to put all that together. I mean, like the machine learning models we see today, they are very, very naive. They're very basic. They solve very singular problems. One of the things that I think is going to happen is we're going to see multi-agent systems, which is essentially large aggregations of machine learning models, where some models will be dealing with collaboration, some models will deal with anticipation, and you will have models competing for control, models suggesting ideas, and models explaining what's going on if that's needed. I just think today we are just really just scratching the surface.
I hope you're right. That's going to be very exciting.
Yeah.
I look forward to seeing that.
So let's get back to the self-driving car, because we have been talking about this for many years. And when you're in California, you see these weird-looking cars with all kind of stuff on them. And so maybe one question is, when do you think we will actually see that happening in the real world, on a larger scale, and not just as experiments, but actually when we will have as a normal thing that we will be among these self-driving cars?
Well,
you want to give us a year?
Well, yeah. I was going to say, you have a background of having done this for Uber and so on, so I'm very interested in your answer to this. Within whatever it is, I'll disagree with.
Yeah, good. I like that. I think that I don't really want to put a year on it.
No one comment.
No, I'm gonna keep that. I'm gonna keep that to myself.
Okay.
Okay. No, just kidding.
Yeah.
I think it's a very difficult question to answer directly. So I will answer it this way: that there are certain things that needs to happen before we can put these cars on the street. Yeah? And there's technology that needs to be invented to do that. Yeah? Such as massive simulation, where the whole simulation technology itself becomes a challenge.
Yeah.
You need to simulate. An experience that corresponds to the accumulated human experience in driving vehicles around for the last 120, 30, 40 years. Yeah.
Would it make sense to actually first build a generation of cars that picks up every information that it can from the driver, from the traffic, from the environment to collect more information?
You can never do this in a real physical world. It has to be a virtual world. It has to be massive generation of driving data that's all synthetic. And the art is going to be in creating synthetic data for training these vehicles. You have to make sure that these vehicles have seen everything that is to be seen on the street and a little more.
But
learn to generalize that and deal with it. That's what I call the cognitive skills.
And that's despite the fact that human beings are actually not very good driving cars, because that actually kills a lot of people every day in traffic. So how perfect does it have to be before we will do it?
So I have a chilling story about that, analogous to that. When I was at Japanese 5th Generation Computing Effort Conference in Tokyo in, I believe, 1989, while I was there, a despondent worker at an auto plant committed suicide by crawling under the safety chains and essentially getting themselves crushed to death by the machine that they normally operated. And instead of this being a minor story of the form despondent worker commits suicide, it was front page news with the title "Robot Kills Worker," because in fact the public, media, government are just waiting for stories of the form AI kills photogenic family of 4, with lurid photos and so on. And so I believe that even if we built autonomous vehicles that were more safe on an annual basis than the cars we have today, even the small number of fatal crashes, unnecessary fatal crashes, like for example with airplanes today, would be what the media and the public focused on and what the government acted against, and so on. So that's in addition to the difficulty of building autonomous vehicles that are better than people today. And I think that there really is a continuum of what we could safely use autonomous vehicles for when, to answer your question. And in the very near future, like 1 or 2 years from now, we could see truck convoys on long-haul interstate routes with 10 18-wheelers where humans are only in the first and last one, and all the intermediate ones are driven completely autonomously, and so on. But if you're talking about driving around, say, the streets of Chicago, I think that without programs that truly have common sense, without programs that have the experience, not just the driving experience, but the experience of knowing what object is likely to be in that McDonald's bag oh, what the hell, I'll run it over. Oh, I know what object's in that Home Depot bag. I'm not going to run that over because I know what I buy when I go to Home Depot and so on. So without something which has the knowledge, what you were calling the simulation knowledge, not just of the driving world, but in some sense, almost all aspects of our everyday life, I think that there are always going to be this small probability of unusual, unlikely, novel occurrences that mess those programs up. And for that reason, I think that the common stereotype of autonomous vehicles is both metaphorically and literally an accident waiting to happen. And when it happens, the media and government is going to jump on that in a negative way.
Well, sure, that's the case. But I would like to ask you anyway, is that intelligent? Because if we could save a lot of lives, having a not 100% perfect system, but we could save hundreds of thousands of lives, but we don't do it because we fear media. Is that intelligent?
Well, it depends on what kind of short versus long-term view you're taking. If in fact we try and do that, it has this negative backlash. It ends up therefore not saving all those lives because people have essentially stopped using it or prohibited it and so on. And if we had just waited 5 more years or 10 more years, then it could have come out in a safe way. In some ways, it's the analog of what happened with Google Glass, right? Yeah. Google Glass is obviously the right winning idea for the future. And if Google had just waited about 5 more years to come out with it, I think it could have dominated our entire world. But now it's going to take an extra 5 or 10 years longer because of the backlash that happened against it.
Then?
Yeah, I think we'll. I'm convinced we're going to see self-driving cars, and I really believe that they have to be so much safer than anything we have. I think we're probably going to expect them to be almost as safe as airplanes. So it's going to require a lot of innovation. I think simulation is the key because you basically have to surpass where nature got us today, which is not okay. Yeah, and so I think it's going to happen. It's going to happen through simulation.
So I would just modify slightly what you're saying. I would say there has to be the equivalent of a model of the world which is sufficient to power those autonomous vehicles and effectively to do the equivalent of real-time simulation of what could be happening given what I'm able to see in front of me and so on. And so whether that model is completely autonomously built up through machine learning or partly through what you might think of as actual explicit declarative modeling of things we know to be true about the world, in the end you have to have this model which is good enough to power these autonomous vehicles, and we are very far from having that today.
Thank you. Just one last question then. Should we fear artificial intelligence?
Oh, absolutely not, because remember, we work in artificial intelligence and they'll remember who their friends are.
Good.
and what's the alternative also is people doing things and making decisions and having power over us. And have you met people?
Yeah, I don't. Yeah, we don't fear it. We know where the plug is. Yeah. I think we should respect that. It's going to be a powerful tool, and all powerful tools should be respected. I think that that we have many more urgent problems. I can mention climate change as one of them that I think we should fear much more, and then we should probably fear AI and a lot of other things far less.
And to give you just a slightly serious answer to the question, I think that the answer is, to some extent, yes, we should fear it, but that AI will actually provide more good than harm. It will take away a lot of things which we currently do fear about the world because we don't understand it, we can't control it, we don't know how to cope, we don't know the right things to do. And so if AI makes us smarter, if AI makes us better able to deal with the world, then even though it may cause some problems, it will solve many more problems than it causes, just like electricity did 100 years ago.
Thank you so much for coming.
Thank you for having us.
Yes.
Thank you for your interest.
Yeah. Yes, and thank you for inviting us to this great conference.
Thank you. You're welcome.